We propose ConCon, a wrist-worn clutch-coupled force feedback device for existing VR controllers. Attached to commercial VR controller, ConCon can deliver various feedback, position control, rotation control, impulsive feedback, and free wrist movement with disengaged clutches. In this paper, we conducted technical evaluations and VR user study using 6 haptic scenarios to evaluate ConCon's capability.
We present HapPalm, a novel interface that delivers rich spatiotemporal vibrotactile feedback through the laptop palm rest area. Our prototype delivers spatiotemporal vibrations for various game events by utilizing a 4x6 array of LRAs supported by a custom spring structure to isolate vibrations and ensure large palm contact. We identified and validated 11 distinct haptic families, enabling the rendering of complex game events by choosing a haptic pattern family and changing its parameters. User evaluations show that HapPalm significantly enhances immersion, realism, fun, participation, and presence compared to non-spatial or no haptic conditions. HapPalm brings rich spatial haptics to the realm of PC keyboard games.
We present Hi-Fi Gaze, a new and accurate approach for gaze estimation on consumer computing devices. We take advantage of continued strides in the quality of user-facing cameras like 4K or greater, such that it's now possible to capture the 2D reflection of a device screen in the user's eyes. We ran a user study, turning on and off different sources of information to quantify their individual efficacy. Our study results show that we can reduce mean tracking error by up to 18% compared to a state-of-the-art appearance-based model.
We present Redirected Pinch, a novel bare-hand interaction technique that combines input remapping with pinch confirmation to enable efficient and comfortable interaction with 2D windows in VR. The technique creates a tilted interaction plane at waist height. Hand movements above this plane are remapped onto a vertical window in front of the user. Please check our paper for more details.
We propose String Touch, non-occlusive 3D fingertip haptic device using string structures. In String Touch, fingertip frame and a Bowden cable system supports 3 deformation modes: normal, shear, and angled deformation. We conducted 3 experiments to assess String Touch's fingertip occlusion, tactile cue delivery, sensory modulation of VR proxies.
In-hand rotation is one of our most natural motor skills. However, current VR controllers rely on wrist and arm movements to rotate virtual objects, leading to significant arm motion and fatigue. Therefore, we propose Twin Spin, a VR controller with 2 embedded mini trackballs manipulated by the thumb and index finger. It uses the intuitive metaphor of rolling a virtual ball between the fingers to achieve 3 degrees of freedom rotation. Through docking tasks and user studies, our evaluation showed that Twin Spin significantly reduced arm movement and task time.
JHHEEPLLLLI-info.
Modern graphical user interfaces often include Z-axis elements like window hierarchies, layer management, and zoom interfaces. However, current mouse devices support only 2-dimensional input, limiting effective interaction with Z-axis GUI. Thus, we propose over-the-mouse interface that uses finger lifting gestures to enable direct Z-axis control. With over-the-mouse, we confirmed that usability and completion time improved in some scenarios of the user study. For further details regarding the implementation, experiments, and results, please refer to the paper. AutoPark, adaptive friction mouse facilitating stable multi-touch gesture input. Multi-touch mice face a design conflict regarding friction. Touchpads provide stable grounding for efficient gesture execution, whereas multi-touch mice likely cannot provide such stability. To address this conflict, we propose AutoPark. AutoPark is a concept of a multi-touch, or MT mouse that transitions between a low-friction mode for precise pointing and a high-friction state for stable multi-touch gestures. Our AutoPark device detects the user's intent on moving the mouse by determining whether the device is gripped or not.
We introduced the 420, a 20-sided tangible controller with independent force sensors on each face designed to support a variety of gesture interactions. Neutral mode includes gestures that can be performed while rolling the controller freely. Three-finger mode enables various gestures by using each finger like a button. We developed a drawing application that works with the Board20, allowing users to perform various functions using Board20's gestures.
While gaze interactive applications involve UI responses, eye movements are often unconscious and reflexive. Although this may not cause false input registration in gaze hand context, it can still incur unintended chains of visual UI responses. This demonstration presents tension and gaze interaction scenarios, where UI elements become gaze responsive only during a designated period of finger-induced tension. 4 example scenarios are demonstrated across both XR and PC environments.